And it should have like
It works.
Yeah. It's 5:30. The workshop is going to start right now. So today is on Thursday. We talk about machine learning and all the different libraries in there. So who am I? My name is currently Rami Ismail. I'm currently an artificial intelligence design mentorship. That's my current Discord profile. I don't have currently an AI Gmail right now, so kind of figure out the structure of this event. So right now we're gonna go over 15 important Python libraries that are necessary. And we're gonna talk, and also there will be a Google Colab notebook. You'll be also following along with the Go, and you'll be like running as time. So this is the schedule for on Mondays. I advise you to all should go. It's really fun. I highly recommend it. It's weird. That's weird. Okay, so basically today you're going to learn the main Python library and create a single project required to use multiple Python libraries. And right now we're going to use Google Colab as the, how many of y'all know Google Colab? Just checking. Okay. Good. So most of you have Python support. And that's over here. And I want y'all to hit the URL link for it. Please tell me it does it. Please tell me if it works or not. Okay. And it looks similar like this, right? So we're going to talk about our first Python library, which is essential. Like, what is NumPy? NumPy is a popular support array which just exists in Python, using nearly every Python module. And this is some basic Python. We have this function will create a NumPy array. I think go to Google Colab here. No. And here. So the first function is just create a normal NumPy and check what version are we on. Then we just create a simple array 1, 2, 3, 4, 5, and interpret the only 8 bits. And we create a number dimension is 1, 5, 8. So next, So what's next? So our next Python library is pandas, a library for data analysis and manipulation, for data structure, for efficient storing and manipulating data in tablet format, offers indexing and so forth. And we're going to do one code snippet. So this one code snippet. So the first code snippet is how to create a simple pandas array for 3 columns, 5 rows. And here we can see you can create a pandas array. Here, you can actually select the column right here. For example, let's say I want only to get the name, John, Anna, Peter, and Linda. I can get here. And if I want to get just select multiple columns, I can actually do that both. John and Linda. Next. Now I can select the rows by the index. So say I want to get the first row, which is John, New York, 24. I can get here. First one, John, New York, 24. So next is I want to select a row by the condition. For example, let's say I want to get the row of all people above the age of 30. For example, that will be Peter and Linda. Both are old. Also, one great thing about pandas, which I actually got interviewed, like basically, if you want to SQL query on pandas A-frame, they'll ask you, hey, you can use SQL query here, and can actually get people who are above the age of 30. Does anyone have any questions? I know I talked a little too fast, so any questions? Good. So next, we're going to talk about our third Python library, which is SciPy. SciPy is a commonly used scientific Python library to create the optimization for function. I'll demonstrate a sneak code snippet next. This code snippet will try and find the optimization. Okay, there's an error for some reason. This is where I assigned the error. So right now we have a function. Let's say x squared plus 10 assigned. You can actually look at demos. Yeah. So this function will actually create the min function here. Next. Okay. Next, we're going to do matplotlib, which is a very common Python library for demonstrating animation, static, and attribute analysis into Python. Here. First, we need to download matplotlib. This is the first. Are y'all getting the same error I do? It's not working for some reason. It was working on my laptop 30 minutes ago, so now it's working. Yeah. It's working. So next, we're going to talk about our fifth one. So basically, the next one is scikit-learn. The scikit-learn contains a large number of pre-processing features, so actually model selection to many, and also furthermore, it can do many Python library machine learning. So right now we're going to have an iris dataset. Just a dataset that has 3 flowers we need to classify based on some 4 features. Right now we have 150 observation, so goes to train data. And for now, for usually machine learning, we first split our dataset. First we split the dataset, then we get the size of the dataset right here. Next is we train the model. So right now we use a decision tree classifier, and that's it. That will be our machine learning algorithm. Next, we call the machine learning to predict on our test set. Next is accuracy. As right now, it's not working. Many things aren't working right now, so we cannot actually show the confusion matrix. It used to work a minute ago, but it stopped working. So next is our. So now we're going to talk our sixth machine learning library. Right now, we're going to talk about XGBoost. It's an open source library for gradient boosting decision tree, providing high performance implementation of gradient boosting for classification and regression problems. The best model for which is currently the best model for tabular data set. And right now, also, okay, so now it's working. So right now, the Python notebook are running. And right now, so we're going to talk about our sixth section. Our code assembly is called XGBoost. And do you have any question about XGBoost at all? Okay, XGBoost is an implementation of gradient boost decision tree designed for speed and perform its tabular data set better than deep neural network. Currently, it does perform better than deep neural networks. Right now, so for example, first of all, as all machine learning, we need a data set. First, we need to create the model instance versus XGBoost classifier. So now we call the fifth method. So the fifth method, all it does is frame our machine learning algorithm. Next, and we have this, also the BS3 classifier has a predict method. This predicts the value of the y-test here, and then we score how accurate what the model is. So currently the model is 93% accurate. So it's a pretty good model for something that's very small and quick. Right now we have to create a confusion matrix. Anyone have any question about what this confusion matrix is? So here. So confusion matrix has, it tells like how correct we know, 0, 0, 1, 1. So all of them are correct for the first label and label, second label, all fine. So next we have to, we're going to talk about Spacey. Spacey is one very popular NLP library for natural language processing. You can do anything like part speech tagging, depends parsing, and name entity recognition. So first of all, we have to download Spacey. It's not working. Luckily we're using Google Colab notebooks, so anytime there's an error, we can restart from this point. That's one thing here. So for our first example, we want to use Spacey for part speech tagging. And do you want me? So part speech tagging is able, if you have a language, usually in English, you have adjective, noun, verb, and subject retention. And the goal of part speech tagging is to classify each of these words into the sentence. For now, let's say we have an example. Apple is looking at bugging UK startup for $1 million. So word Apple is the pronoun in the sentence is the auxiliary of the action verb. And we have the word at, that's the adjective. This will be very helpful to give us extra context when creating a machine learning pipeline for natural language processing. So for example, the part speech tagging, let's wait until this notebook after it runs. So right now we have also one requirement is called again. We'll wait into that. So next we're going to talk about our, this is our 9th Python library right now. So we're going to use something called datasets. And right now we're doing machine learning. Machine learning requires actually using a dataset. So luckily there's a collection of great fun datasets on Hugging Face Hub, where you can download or stream with data to train machine learning model. If you understand machine learning pipe, so let's say Hugging Face Hub. All the way to Hugging Face Hub, and you can see all of these datasets you can use. Glue, benchmark, Flynn. So if you're interested in using any data set, you can go here. Now, so until then, we're going to talk about the next one. So right now we're going to talk about our first deep learning framework, which is, I think, the most important machine learning library right at this point. TensorFlow is make it easy for beginners and experts to create a machine learning model. It was developed by Google Brain. It's used in many Google products, for example, ChatGPT. Finally, so we'll just wait until this plays out. Anyone have any questions so far?
Do you have access to that? Like,
Oh, yes. Yeah, so that was free. Everyone has the Google Colab notebook. So basically start working now, and we're going to talk about this. Next, we're going to talk about name entity recognition. But it's basically Python library. So right now, Spacey is a very popular thing. For example, say when Sebastian Turin started working on self-driving car, I Googled 2007. So currently, name entity recognition is that, for example, the word Sebastian is a person. And currently, there are other people here. We won't say your name. Next is Google, which is the org, and the date 2007. Help us give extra context for our machine learning pipeline. So right now, we're going to download the Python library. So, for example, there's keep getting errors for no reason. Right now, we have to restart a notebook, and it's going to start from here. This time, we're going to install the dataset library. For example, let's just talk about the datasets while we're waiting. For example, go to OpenAI Human Eval. So this is a very common dataset for text. For example, you have large language models. For example, ChatGPT, GPT, and StarGPT. Usually, you can generate text and code. So the way they evaluate data text is using this dataset. For example, load eval human eval. And luckily, for the Hugging Face API, you can actually download the whole entire thing and use it. And you can actually view the dataset right here. With dataset viewer, for example, let's say I have a prompt from typing the list of close number elements. Here's the actual solution. And then you also have tests. So this was also very contributed a lot. It's that ability for everyone to work together digitally online. And you can test each other model and test guidelines. So now finally here. So we're going to download our first NLP, natural language processing text classification data. So this data set is called tweet eval. So you have a bunch of tweets, and you're going to evaluate based on what type of emotion you get from. For example, here is our first data set tweet eval. You can look at, you can actually call the data set, get the relevant emotion. For example, train, test, and validation. And your first sample is worry is a down payment I'll probably never have. And then you can label. The label 2, which is the label 2 right here is a joy statement, joyful statement. And this is really helpful to create our own machine learning pipeline. So next, we're going to talk about in the dataset pipeline, shifting call, you can actually stream a dataset. So streaming a dataset, for example, this current dataset is called co-pair GitHub code. This dataset is actually where this one person downloaded the entire code in GitHub, like the entire thing. So right now it's over 100 gigabytes. So there's infeasible to actually have it up and download your local PC. So what we have to do is actually stream like snippets of each time dataset as you go through. So I'm going to show you a function here. You see here, you have the code, the repo name, the path. See the whole entire function. Next. And the way to do it is you have to call next and iterate. So go on. Okay, next is a computer vision data set. Okay, everything works fine. And you can actually, next is the how you pace pipeline. So it's not only actually processing right here, it's actually a lot more. For example, data sets can be for many things, and we have multimodal computer vision, non-linear processing, and audio and tabular method. So right now, the next one, I'm going to show you a computer vision one. This computer vision one is here. This one, so here is where you have to download something. You have a little data set. This one is just Pokemon classifier. You just download the data set of Pokemon. One part thing was all from how you face up, and all download on your local PC and run. So now you have any data set you want, you can just run. So next, we're going to talk our first deep learning framework, which was TensorFlow. So I know y'all have heard deep learning before, I assume. I assume y'all use at least a deep learning framework. How TensorFlow or AI much in deep learning. And TensorFlow is one to use deep learning for AI. So our first code snippet is like how to create a algorithm machine learning perception. How to create a neural network, very simple neural network that can classify images. C410. C410, basically C410. This bunch of 10 classification: airplane, automobile, bird, cat, deer, and dog. What it does, and we have a model that can actually train. First of all, we have to get a data set. We have to standardize our data set, and this function is where you create the perceptron layer. So you have the first flatten out. So first of all, you have an image that will feed into our neural network. We have the first flattened image because neural network only taking layers at a time. I'll put the ReLU layer here. And next, you have compile method. First thing is to have a compile method, which just chooses our optimizer, our loss function, and our metric. Right now, our metric currently accuracy, that's what we care about most. And currently, it's right on train. That would just be our small code snippet. And if you're all interested in working on your TensorFlow knowledge, I'll advise you to go through the TensorFlow documentation. It's really, I highly recommend it. It's really good. So next, we're going to talk about our next one. Right now is PyTorch. This is the second popular deep learning framework. Right now, which I personally use, I'm highly recommend. It's really fucking good. So PyTorch is open source library by Facebook, dynamic computation, and then confirm building and debugging compared to. And also feel like it's better experience in TensorFlow. So we're going to talk about how to build our first PyTorch. So I assume y'all understand how neural networks work. Am I correct? I don't feel like everyone knows how it works. Okay, I'll show you a quick demonstration of how this neural network works. Here, so usually you have an image. That feed into our neural network. So neural network, that feed into the alpha and has layer. So neural network has some components. First, we have the first layer, the second layer. And currently they have, and each layer is connected to another layer. Here. And so you can view it as a bunch of neurons. So this here is really function. I'm like going through right now. So we just created regular PyTorch here. And next we have our create neural network. Next we have to initialize a neural network, compose it, define the batch size. Next is load the data and feed into our data loader. Next we have to pick our classes. And next we have to create our cross loss function and an optimizer. Next, we have to go to our train function. First, to create a neural network, we have to first get our data, zero out the gradient, output the model, compared to our loss function, which is cross-entropy loss. And then we have the backward pass, and we just update our function as we go on. Just take some time. While we wait. Okay, so right now I finished training. So next what's our next one? So next we're going to talk about the Gluon AutoML library. So it's developed and trained deep learning models. Gluon provides a high-level API for building, training, deploying neural networks, and creating low-level API. Here. So when we start using AutoML stuff, so we're going to have to first download our Gluon. First, you have to download the Python library Gluon. So Gluon is currently, we have deep learning networks. Currently, deep learning is kind of like an art, but right now we're trying to make it like an actual science you can actually automate it away. So replacing a lot of data scientists, engineers, and much more. Could allow you to be unemployed after this, but it will be very helpful in the future. First, we have to wait until the Python library actually download. Oh wait. So while we wait, while we wait until this library actually wait to download, take some time as always. Here. So right now let's just talk about what we're doing in our code snippet. First we have to wait for the download library. First is when we do machine learning, we have to create a data set. Grab our data set. So that's our train and test data set, and which is downloaded from the AWS SageMaker. First, we have to get like a sample of data set to make sure to just quick demo. Next is here. Next, we have to create a multimodal predictor object. A multimodal predictor model is we have a data set, and based on whatever modality data set, for example, it's image, audio, text, or any other type, we can actually start classifying. Right now, our multimodal predictor will start labeling, which will only do label and value to accuracy, and this is our path to a model, which is here, which was downloaded from AWS. It's a long time ago. Here is this. We have so after we have a model that is fit, which is our fit method is where we actually train the model. This is where we train the model function. We went until then we wait until like this whole entire library is downloaded. Usually does not take this long, but while we wait until that, we can talk about the next one. So right now we're going to talk a second AutoML library because there are multiple more. This one specifically is more focused on hyperparameter tuning. Right now there is machine learning pipeline. There is currently machine learning, and you usually have multiple hyperparameter, which is learning rate, batch size, weight decay, any number of layers in here. So right now we're not going to do a hyperparameter tuning on PyTorch. We're not planning to do that as it's computationally really hard to do. But I'm just going to currently use the same method. For example, we have all the way to SciPy. We create all the way to SciPy, we already created here. So we already create a function here. So our function, x squared plus 10 npy sine. We can use optimum to actually find the minimum point in this graph, in this function. So instead of our approach, this is how here. Damn. I think it's so long. So right now, I just start running the Gluon code, multimodal. This actually produces errors for some reason. So that's how running the machine learning works. So let's talk about, we're going to start using Optuna now. We'll fix that up later. Next, we're going to first install Optina. I'm going to use the Optina library to find the minimum point in a function. So as here in Optina, we actually have our image. So at point point 1, like we start here, as we keep going down the line, we see as we find more minimum point here as we go on. This is going to show an example as we're going to hyperparameter tuning. We're going to choose the best hyperparameters to train. So next is after we finish our AutoML library. So next we're going to talk about more deep learning stuff. That's currently what y'all are hopefully interested in. If I'm interested in, currently computer vision. TIM is the most popular computer vision library to do mostly everything on the highest one and create 700 parameter model, and is designed to be flexible and easy to use. With TIM. First, we have to first install TIM here. Next, for this demonstration, we'll be using TIM to just do inference. Just give us an image, and we're going to classify the image based on from 1,000 samples. So this data set is from ImageNet. Let me translate. Here. So now we have our image. So now we have our value. So we have download data from here, image, transform here. That's fine. So now, So next, we're going to talk about the diffuser library. So I know y'all have used Stable Diffusion before. So this diffuser library makes sure to be able to just download diffusion for you, running on a GPU on Google Colab. First, as always, it takes some time to download all the Python library. Okay. Next, afterwards, so we're going to download a model from the Hugging Face Hub. So the Hugging Face Hub is this. We can see a lot of different multimodal computer vision processing. Right now, we're doing image, text to image. So Stable Diffusion, and this is our model of choice. Using this, you can actually create your own Stable Diffusion model. Well, it takes some time. It usually takes 3 minutes to run. And I think this currently is a good thing to use. So let's wait for it. As we wait for it, so we're going to talk about the Hugging Face library. So currently, we're going to talk about the Transformer, a library for non-image processing based on natural language architecture. We probably state-of-the-art pre-trained model for variety of tasks. Right now, it can do natural language processing, computer vision, audio, multimodal, and currently reinforcement learning, and many more. So we go all the way to the Hugging Face library, so NLP. So right now, this model, so first of all, to create a transform, you have to call the pipeline function. Pipeline function is just, it's something that we usually apply a lot constantly currently doing deep learning. So this currently we're going to do a classifier. It's zero-shot classification. Zero-shot classification is that you have no example in classified image. And this one specifically can actually do any languages, probably 1,000 languages. Right now, let's talk about Angela Merkel is a politician in Germany. And next we have a certain candidate: politics, economy, entertainment, and environment. We can actually output the classifier. And sequence the candidate label, the output to the classifier. Eventually, currently they're on one label, so we have to specify multi-label equals boss. Eventually, session just crashed. Next, we're going to talk about how to use some summarization. So next, we're going to talk about how to use the Hugging Face library for summarization. So right now, for Hugging summarization, is that we have a text, and we have to download a model. All we have to do is call the pipeline function. Currently, the pipeline function will just call a specific model called this little bar, CNN 12.6. You want to learn more, you can always go to this Hugging Face pipeline. They'll give it a good description of what it does. And you can also compare it to other models. Summarize text sample, and actually currently we wait until the model loads. Or in your free time, you can actually run the model on your CPU, on your Google Colab notebook. Second one is right here. Next library is for now you can use to like fine-tune. Fine-tune is able to have a good small BERT model and actually train on your own data set. Currently during the fine-tune process, we have a neural network model. So we have currently we have a model with a classification end. Following the train argument, eventually we have our argument for our train pipeline. Currently it's on train, so have a train object, we have model arguments here. Eventually we have a code train.train, and eventually get the output. So now our after stable diffusion pipeline actually works now. Here, fine. So use a stable diffusion model to generate an image. Check this. You can choose to generate your own prompt. And we have a prompt, and we actually get a new image, and you can choose whatever prompt you want. And anyone have a prompt you want to try out? No. I don't know, big red dog named Clifford. Okay. So and plus you can add like more stuff to it with a leash near a tree. Yeah, so and plus you can add much more detail to it, and all you have to do is just call this. All you have to do is just call these. It's only 16 lines of code, and all you have to do is create your own stable diffusion model pipeline. Next, we're going to talk about zero trust classification. We have a model right here. Download the entire model from Hugging Face Hub, which is a class to zero trust classification. Oh, okay. We can send this some stuff. Yeah, we can start. We can have download a second model. It's a whole entire Hugging Face pipeline. This model will definitely for summarization, and this summarization is quite long. This is talk about the description of the Eiffel Tower. Really long, and currently you want to summarize it because there's many benefits in summarizing text. just UT Wi-Fi is by itself. Lightweight. At the end, like, really? Questions? Anyone have any more questions? Any library we can discuss about? Probably. No questions? You can wait until here. The model right here is able to summarize our text. So this is the description of the tower and the upload centers. Tower is 300.24 meters. Here. Next, at the end, we want to talk about how to fine-tune a whole cardinal network model by scratch. Right now, we have a regular data set. Basically done. So that's it for our workshop. And there's no more Python libraries to learn about. That's it for our workshop. If you have any more questions, I'm here to answer all your questions. I have plenty of experience. I think that's it. No. If you have any more questions, I'm here. I'll be staying here afterwards.
If anybody's interested, AIS is also having a kickoff where we can learn a bit more about what we're doing this semester at 7. So maybe y'all can like chill in there, and then our kickoff is in ECS West in a really big room there. So we can learn more about like what we'll be doing on Mondays, and we have some other stuff that we're going to do for this semester. And we do have pizza in limited quantities for those who RSVP, but like in the case of we have extras, then you guys can definitely get that too. Thank you. Thank you.
How can I learn more about like specifics? Like there's a lot, like I'm looking through the notebook, there's like a lot of different like terms I'm not familiar with. So like I guess how would you
can you please, so are you talking about how to create your own neural network or like?
No, I mean just like in general, like there's things like I guess like a diffuser, like I don't know what a diffuser is. Like how would I go about figuring out what a diffuser is?
How would we figure out? So there's currently a Hugging-based course about diffuser. And plus they have amazing documentation. For example, let's say, what do you want to do with diffuser, honestly? What's your purpose? Like, what do you want to do with it?
I don't know.
Okay.
I'm curious what it was.
Okay, so if you're curious what it does, you can actually go to a lot of image to text. And you compare it to other stuff. For example, text to image. For example, let's say I want to create an open journey, a waifu. You can actually look at the output of the model here. Yeah, actually, I want to go collab notebook on all. Anyway. While this one will take some time. Also, you can do Emerson. There's so many of these waifus. There's Nitro. Which you can do other stuff. So if you have any, if you want to find inspiration, you can just go to Hugging-based help and look through it. But if you're asking like how to create your own pipeline to create your own site for stuff, you mean?
Nah, well, yeah, I was trying to just like understand like the basics.
Oh, basics. Okay. Number of currently, there's a Hugging-based user. This is where you can learn about the basic of diffuser.
So we have like a bunch of different courses I can look up. So Honeybees like has a bunch of courses on it as well.
Yes.
I'll look for that. I've been curious about this stuff, but I had no idea where to start. So,
Okay.
lots of things.
So yeah. So fine tuning and guidance, stable diffusion, and doing more with diffusion models. All here. All you can just read for fun. Stable diffusion use this. Yeah.
Alright, I'm gonna head out, but I'll see you, bro.
Okay.